Mathematics can often be considered as the science of patterns, and series and the different applications that come from it can be very useful. So a couple of definitions to start off with. A sequence, sometimes called a progression, is just simply a set of numbers that follow some pattern. So that's what we call a sequence. A series is when we add the numbers together. So the only difference really is when you see numbers that go like 2, 4, 6, 8, that's a sequence or a progression. Whereas when you see 2 plus 4 plus 6 plus 8, that's technically a series. But often those names get interchanged and it's not that big a deal. But technically, they are the definitions. A is, of course, the standard pronumeral we use for the first term in any particular number pattern. Term n, or the nth term, is t with a subscript of which particular one it is. So I suppose we could also, instead of putting a, write t1. And Sn is, in fact, what is the total of that series. So if we did add up 2 plus 4 plus 6 plus 8, so sum up to however many terms we're going to do it for. So an example, there's a formula to work out a particular number pattern. We're going to square the number and add to it each time. And so if I wanted to work out the fifth term, and that's just basic algebra substitution, so the fifth term of that pattern would be 27. Sometimes we want to know whether a number is a part of a pattern. I mean, we don't have to write the whole pattern out. If we know what the general term is, we simply have to see whether n turns out to be an integer. Because obviously you can't have the third and a half term. We need to have a whole number. So can n squared plus 2 equal 42? Well, no, because that would mean n would have to be the square root of 40, and we don't know exactly what the square root of 40 is. So it's not possible for 42 to be a part of this pattern. So no good, not an integer. Now there are two specific types of series we like to look at, and they are the arithmetic, and remember, if you don't remember how to spell arithmetic, a red Indian thought he might eat turkey in church. Okay. And the other type of one we like to look at is geometric. Let's have a look at our arithmetic one. Sequence of numbers in which each term is found by adding a constant amount to the previous term. So that constant amount, cleverly for the common difference, we use the symbol D. I mean, how they think of these things, it's beyond me. So technically, we could work out the difference by simply getting the second term and subtract the first term, and that would tell us the difference. Or I could get the third term and subtract from it the second term, and that would tell me the common difference. Or I could really get any particular term and subtract the one before it. In fact, we don't actually need consecutive terms, because if I had the fifth term and the 12th term, I know that the difference between the two must be 7 of those common differences. So from this we can work out a formula. We said term 1 is always symbolised A. So therefore term 2 would be A plus a common difference. Term 3, A plus 2 common differences. And pretty soon we see the pattern emerging that I can work out any particular term. As long as I know the first term, the common difference, then I can go, well, it's going to be A plus 1 less number of differences. And that will get me the particular number in the pattern. All right, they're telling me term 3 is 9, term 7 is 21. Come up with the formula or the general term. And, okay, they haven't mentioned that here. We're assuming this is an arithmetic. So, all right, I know A plus 2D is 9. I know A plus 6D is 21. So, therefore, the difference between the two must be 4 common differences, just like simultaneous equations, really. So, the common difference in this case is 3. And we can sub back in, and by coincidence, the first term in this pattern is 3. And when you now look at the pattern, oh yeah, that makes sense, doesn't it? I mean, they're multiples of 3. 9 is 3 times 3. 21 is 7 times 3. And so, just to confirm that, if I didn't see that straight away, I could put it into A plus n minus 1D. I get 3 plus n minus 1, lots of 3. Sure enough, that tidies up to be 3n. So now, if I want to, I can find any particular term. Term 100, well, it's got to be 3 times 100 is 300, and so on. If I wanted to find the first term greater than 500, well, then all I'm really saying is the general term, when does that get bigger than 500? Solve that inequality. So 3n's got to be greater than 500. N's greater than 500 over 3. But obviously there's lots of numbers that are greater than 503. Remember, we're looking for integers. So every time n, any integer bigger than that, will give me a result that's greater than 500. We want the first one. So the first integer bigger than 500 on 3 is 167. So term 167, which would turn out to be 501, is the first one. Okay.